Hey everyone. We're still waiting for a couple of people to come into the room, but while we wait, well, for 10 years ago, I was on the stage for the first time with a colleague and a couple of colleagues in the room, and it was amazing. So it's really cool to see this conference going for so long. I'm very excited about all this. The topics that we're talking about, they change over the years. The community stays super awesome, and it's amazing to be here. So thank you so much for being in this room and listening to my colleague Ajesh and I. Today, we will talk about low effort and high impact app optimization. So that means performance. And well, when it comes to performance, many of you might just think of one thing, and that is, in the app release notes, you see bug fixes and performance improvements. Who of you has ever written this? All right, I have too. Who of you really meant it or were just too lazy? Did you mean it, or were you just too lazy to kind of put it in there? Just too lazy, crew? Me too, sometimes as well. All right, but today, we want to make sure that you really mean it when you write it. Mainly because when you have an app that is not really performing that well, that's okay for some time, but actually it's really not. Because when you prioritize having a new feature in there, and it takes a long time to load, your users will become frustrated. And frustrated users are unhappy, and they're more likely to abandon the feature that you spent a lot of time working on. Is it a thing you want? I don't think so. And this is why we think that app performance is a core part of your app's user experience. And with it's highly related to user satisfaction, as well as it can lead to higher retention and engagement, and to things like improved review scores or a better bottom line for your app as well. We are doing a Spotlight Week in a couple of weeks on performance. You might have seen it. So today is, next to an additional thing that we don't talk about in the videos of Spotlight Week, also a sneak peek of this Spotlight Week. In the Spotlight Week, we'll talk about the R8 optimizer and a couple of more things, and we'll talk about it today as well. Who in here has used R8? Cool. So let's get started. We'll talk about best practices as well. We'll talk about improved tools and tips and tricks in this. We'll also cover a couple of other things: baseline profiles, startup profiles, and a bit of benchmarking, because you really need to know how your app performs and how it performs afterwards. So when you have done the optimizations, there will be things better. But why should you optimize? It just runs fine on my device and on the device of my product manager or my CTO or whoever. So why should you? Well, let's take a look at a real-world app. The Reddit app is quite well known from a lot of people, and they took the app performance score. And it's a score that helps developers to see how well an app performs in certain areas. And then they decided to take a look into optimizing R8's full potential. What they've seen is 40% faster cold startup time, which is extremely important. And it leads to a much snappier user experience. So that means the app starts up, users don't want to wait for anything here. Another thing they've seen is a 30% reduction in ANRs. ANRs is one of those, well, it's Halloween, so it's one of those spooky words. Right? Everybody's like, nah, really, how do they work? What's going on? We'll talk a little bit more about that in depth later. Also led to 25% improvement in rendering across a variety of devices, especially on the low end. And all that also reduced the app size by 14%, which means that the download and installation time is faster as well. They used analytics, they used Android Vitals, they used Crashlytics, and they captured all these metrics on real-world devices. So this is not a metric that is on some specific device, but what has happened out there with their users. And being an app that is being used globally, this is amazing and very impressive for them. They were very excited about this. And they also saw positive movement in business metrics, which then showed them that there's users that are way more happy than they used to be before, which reflected in ratings and other metrics as well. The coolest part about this, they had an engineer working on this, and we talked with him, and he said enabling the full potential of R8 took him less than 2 weeks. And if you consider the short time that it took for that, it's really high impact at very low effort. And I recommend you enable R8 today, because you really want to reap all these benefits. We'll show you how to do it, and we'll show a couple of the pitfalls along the way. One of the things, again, if you want to have faster startup, and improved rendering, that is visible. That's visible to your users. And if it's visible to your users, it is linked to their satisfaction directly as well. And the optimizer improves those. As we've seen this time and time again with other apps, and you really, really want to take a look at that. So we have, again, just because repetition works as well, we have faster startup for this, where we said this is really important. The rendering improvements, we've seen them across the board. So anybody that's seen issues with any rendering of any kind, before you do anything else, before you try and do all the other changes, like making difference in the way that you do your composables, different ways that you kind of have anything in your layouts, make sure to lay the foundation. And R8 is part of the foundation of anything that you have to do with performance. The A&R reduction, we have not seen anything else that is as significant as this. And what it does is R8 optimizes your app, and it reduces so many things. It reduces, for example, also memory usage, because code runs more optimized. That means your app will use less memory. If you've ever had to deal with out-of-memory errors, you usually see them in the wild, not locally. They happen at random times. What's going on? If you want less of this struggle, spend some time on optimizing your app with the R8 optimizer, because we've seen those go down dramatically as well. Another one, CPU usage, because that means the app runs faster, the code is more optimized for that. So that improves how much usage is used there. So your app can run smoother on that side as well. And like I said, installation size is a big one as well. We've seen all of that, and I mentioned it earlier, but let me go into a bit more detail. So with user satisfaction, that's kind of what does it mean? So that usually leads to things that your users see things like users are more retained in your app, and they have more engagement, and their sessions are longer. We've seen that with a good handful of partners, seeing this consistently improve all the metrics that they've seen in user satisfaction on that side. Another one that's really important for many apps is user stickiness. So that means daily, weekly, or monthly active users. All of these users are using the apps longer, are coming back more often as part of this. They've seen this straight away after using R8. Another one is ratings. Ratings have improved. Correlated to that directly, we've seen app has been rolled out with R8, ratings have improved afterwards. Not because of other features, but because of these improvements. We'll share a bit more in the Spotlight Week, but that's all I can give you today for this. So many of you might have heard that premature optimization is a fallacy in software engineering, but this is deliberate performance optimization, and I consider this a virtue. Taking care of your performance, of your app's performance, is a core value that you have to take care of. If you don't do this, you will have unhappier users, and while some of us might be in for other reasons, I do this for the users, for the people that use the apps, for the developers, and this is why I want to help you with this. And if you want to make your users happier, one of the key things that you can do is making sure that the app works well. And then comes the R8 optimizer. For a long time, we've seen this as a tool for shrinking and minification, but actually it is an optimizer. It does these other things as well, but optimizing your code, that's where the true potential of this tool lies. It takes a lot of steps to improve the app performance, and there's a lot to cover. Like, there's many, many different things, so we're not going to go into all the details, but I'll give you a quick overview. Firstly, and most important, is tree shaking. So what it does is it takes looks at your app, sees what's going on, and removes unused code from libraries or dead code that is within your app, and removes all of that so the app gets smaller. So this is one part that significantly reduces your app size. Another one is method inlining. So what it does there is it replaces the method calls with the actual code. While it seems counterintuitive, it speeds up the performance of the app. Another one is class merging. So it merges different classes and different parts to make the code more compact. Again, making it smaller, making it run faster and smoother as well. So things like you spend so much time on all the architecture and making sure that everything looks nice and tidy for when you write the app, which is super important. But at this point, all of that doesn't matter anymore, because optimizing for the compiler is very different than optimizing for all your colleagues. Both of those are important, and at this point, class merging just removes everything of the implementations, any interface that you have, any hierarchies that you have, they just don't matter anymore. And then code minification comes in. Code minification essentially means that you have something like my data model, and you might end up with something like A. That basically takes all the names and removes them, makes them shorter, makes them basically meaningless, so you don't really know what's going on. And the main reason why it does that is for making the app smaller again. This is not for security reasons, but just making it smaller. and again, run faster as well. And it also takes care of resource shrinking. Resource shrinking used to be way more important when there were a lot of XML files and things like that. With Compose, it's not that big of a deal on the overall scheme of things, but it still removes all the unused strings that come in from all the libraries, all the translations that you don't ship in your app, all the images and resources that you don't use for your app. Everything is being removed, and it's being stripped out of the app. And that is super important as well, because in the end, you want an app that's also fast to install. That's what you get from that. So let me show you how to use R8. The first thing is, many apps that are older have a legacy app, or basically an app that has been used for quite a while. They might have this in their app, which is somewhere in the Gradle properties that's enabled. This one disables full mode. So the first thing you need to do is remove that. Just make sure, remove it. That alone will give your app a significant performance boost on the next build. But only if you have enabled minify and resource shrinking beforehand. And here you have a thing, you have default ProGuard files, which is a legacy name as well. But we have this file, which is ProGuard Android, and another one, ProGuard Android Optimize. Kind of a hint here already, but which one do you think you should use? Is it the Optimize one or not? Let me show you why. We've tried it with the Androidify app. And it's a small change, but we have the ProGuard Android TXT, which is one of the base files, which brings in a lot of things for Android keep rules and things like that. And it also has don't optimize as one of the flags in here. Ajesh will talk a bit more about this in a moment. But when you use ProGuard Android Optimize, this enables optimizations. Removing that allows the optimizer to actually do its job and not just do some things and keep your product owners happy because the app isn't crashing. It's a seemingly small change, but what we've seen with the Androidify app is after just removing that flag, the app startup has improved by 30%, and the rendering has improved by 23%. So it's a good reason to use that. After we've seen that, we also decided, instead of me just talking to a couple of people here, let's make a flag in Android Narwhal. So Android Studio Narwhal has now has a warning from lint. If you use this file, then you will see this as a lint warning right away. Starting from Android Gradle plugin 9, we're not supporting it anymore. We're skipping deprecation. This file will just be not supported anymore. You should use the ProGuard Android Optimize, and if you don't, well, users are not going to like that. Speaking of a couple of changes with AGP 9, we want to make it more streamlined for you to do the right thing and not talk about minification, because why would you minify? It's like you don't really need that sometimes. At least that's the perception that many developers have. So now we're talking about the new API, which is optimization. It's an incubating API. Some things might still change, but essentially, with this new API, we have optimization enabled true, and that is a lot more in the direction of where we want you to think about this as well, that this is an optimizer rather than a tool for minification. You have the possibility to add multiple keep rules. There will be some changes, especially to that part. But this is the current snapshot I want to show you because I think it's really exciting. Another thing is sometimes you bring in a new dependency, a new library, and there's problems. The new library crashes the app all of a sudden, and you have to spend some time to debug it. But now you can just ignore that broken library for now. So instead of having to stop a release because a new library comes in, you can take a small performance hit for a new library that you bring in, do the whole thing, and then take a look at it afterwards. Or, on the other hand, when you're working your way towards enabling R8 in full, you have the possibility to add package scopes for apps, for libraries, or parts of your code where you know they fully work. We know that the Android X libraries all are fully optimized and work very well with the configuration that they have with R8, so you can just add those straight away. Or, if everything's enabled, you really don't need those flags. So, you should really enable R8 today, because, I mean, what could go wrong? It's not that big of a deal, right? Has anybody seen any problems with it? What's the problem usually? Okay, and what happens then? It crashes? This can't be. It's like not that bad, right?
Yeah.
Ajesh?
Really? Okay. Let me see what could go wrong, and I'm going to talk about how that's why it crashes and what could you do with that crash. So, what causes R8 like what causes the crashes in R8 Minify builds. So when R8 is doing all these optimizations, it could remove some of the classes, methods, or fields that is indirectly called, like reflection. So R8 can't identify the usage of it, and it just removes those classes. So during those optimization process that R8 does, such as method inlining or tree shaking, the methods removed could result in a class not found exception or no such method exception. What you need to look out for is reflection usages in your code base. So these are some signs of the reflection. Like if you're using any of these packages, you could be using reflection in your code base, and you should be looking out for these issues. And some other examples are like if a class is initiated using a class name or calling constructors of a class dynamically. So that's where a keep rule comes in. And keep rule is a set of instructions that prevent R8 from optimizing certain parts of the code. They are often misunderstood and removed from your day-to-day code. So let's see how to set one up. So when you enable R8, this is the configuration that you could see in the build.gradle file. So you could see a prograd file block here, and that contains a default prograd file DSL, which gives you an option to provide a default keep rule file. This prograd Android optimize.txt, it comes bundled with Android build tools, and it handles scenarios like working with enums, parse levels, etc. So you want to include this, and if you have reflection in your app-specific code base, like in your app, you can define keep rules in your own custom file. You can name it like we have named it keep rules.txt. You can define it on your own. Let's see how to define a keep rule. And yeah, so it starts with a keep command modifier where you define the keep. Like you could also use keep class members or keep classes with members. Here I have set keep, which basically keeps the class and its members. You could define optional modifiers, which does more on top of the keep command modifier. Here I have defined allow obfuscation. So basically it means keep this class, but obfuscate it. Then you define a class specification where you define which class to keep, and then you define the method that you want to keep. You could also list down the members, fields, or anything that you want to keep in the curly braces. So the entire keep rule looks like this. For more information, and we have updated our guidance, and we have some in-depth information there. Check it out in this short link. Keep rules are at the core of R8 configuration. So let's take a moment to talk about the best practices and common pitfalls. You should avoid using some of the global options in keep rules that turns off certain aspects of app optimizations, such as don't optimize. This is an important global keep rule. Using it effectively disables any optimization that R8 can provide you for your app. Adding this rule in a release build will result in a significantly larger and slower app for your users. You should never use this rule in production. Then there is don't shrink. When you add this configuration, you are telling R8 to stop removing unused code and resources. Adding the don't shrink keep rule means you are shipping a bloated app, forcing your users to download a much larger one. Then there is don't obfuscate. When you use this, you are telling the build tool to skip the renaming process. This is a key minification step where R8 renames your human-readable classes, methods, and fields into shorter names, saving a huge amount of space, significant in a larger app. While you might use don't obfuscate during debugging to keep stack traces readable, you should always minify your release build. Also, when writing specific keep rules, there's a common pitfall we have seen. This is the inversion operator, the exclamation mark here. So the problem is this rule does not mean keep the classes that are outside of this package. it means like keep every single class in the entire application that are not in the specified package. This one line will match all of your app's code and the internal library code, and you have effectively undone all your optimization with this single one line. Another common pitfall is using the broad package-wide keep rule. A rule like this one will keep every classes in the package, methods, and fields. This prevents R8 from doing its job for all affected code. It can't shrink classes, obfuscate, or minify. So we really don't want you to use this. And that's why with Android Studio Outer feature drop, we have added inspections. These inspections will tell you when you write a keep rule that is preventing optimizations from a significant number of classes, just like this one. This is a sign that you need to define a more specific and a narrower keep rule. Speaking of narrower keep rules, let me show you some examples on how to write a narrower specific keep rule. So let's say you have multiple classes that you need to prevent R8 from optimizing. You could write a keep rule to retain only those classes using extends class specification. Like here, I have certain number of classes that is extending a base class. So I just want R8 from optimizing those classes. So I just added keep those class members and extending my base class. And I have specified a method that I want to prevent R8 from optimizing. In the case of an interface that is being used at multiple classes, I could write keep class members and do the same with implements class specification. Another way to write a specific rule is to use an annotation. So if you have classes, members, or fields annotated with an annotation, you could write a keep rule that targets all these classes and members, and then tell R8 to prevent this. So here I have written a keep rule that basically tells R8 to prevent optimizing all the classes that are marked with this annotation. With all these keep rules, you should be specific about what members you keep to get the maximum optimization. In the cases where you find yourself adding a broad keep rule, like a package one, you need to investigate exactly what's causing the issues with R8 and write a more specific and a narrower one. For a deeper dive, check out the guidance on keep rule best practices in the short link. So after all this theory, let's see an example where I can see a crash and then now unobfuscated one. So this is what it looks like when R8 is enabled with unification. Loccat shows a stack trace like this. The names are obfuscated, and I can't really find the root cause of this issue. So in order to help you with this, we have introduced automated loccat retracing. It is available from AGP 9.0. And what it does, it basically deobfuscates the stack trace by reading the local mapping file in R8 and applying directly within loccat. So this is what it looks like when in AGP 9.0 for a R8 minified build. So you can see the class not found exception. We can see the main activity method that caused a crash. And I can see the line number where it is starting the crash, like the root cause. So this is an example that we added in Androidify. So this is the class that is being called on that method. Here we can see that there is a class for name line, which is basically using reflection to call the run method in that class. So here we are using a reflection from using the class name. And this is causing the crash. So the class name that is being passed is a class that is extending startup task. So I want to prevent these classes from getting optimized in R8. So how do I write a keep rule for that? So I have written like a class, like keep all the classes that implements the startup task, and then keep the specific method that I was running. That keeps run, and that solves the issue. During debugging, if you are unable to find issues using these tools that I have just described, you could use the metadata that is generated during every build. The configuration file, which is part of the metadata, can be particularly useful. It contains all the key rules that are applied to the app, both from the app itself and from any included dependency. You can find the configuration file inside the project's output folder, and you can debug from that. If you don't get answers there, you could see, use the why are you keeping configuration option in keep rules, and that outputs a path from the kept code to one of your app's entry points. And it lets you know why a piece of code was kept, and then you could debug that as well. All Android apps relies on dependencies. So, whether you are an app developer or a library developer, there are certain things you need to be mindful when working with R8 Optimizer. If you are a library developer, you should make sure that the app developers can easily incorporate your library into an R8-enabled app. That means you should choose CodeGen or Reflection whenever possible. If that's not possible, in order to make sure they are compatible with Android optimization, without additional steps, you could specify the keep rules. There are two distinct types of keep rules that you can have in libraries. One is the consumer rules. This is where you specify whatever the library reflects on. These are bundled into the library artifacts and gets consumed automatically during Android app optimization when the library is used. So you define it in consumer proguard files property in the build.gradle file. One thing to avoid is any global options like don't optimize, don't shrink in the consumer keep rules. Since these rules are merged into your app configuration, you would be forcing every app that uses your library to completely disable R8's optimization for their entire project. So don't use that. Another keep rule that you could add in your library is the internal keep rules. Internal keep rules should contain the keep rules that are applied to your library when it is built. It is used to protect your library's private implementation details from being removed by R8 during your library's build process. As an app developer, make sure to pick libraries that work well with optimization. This could mean choosing libraries that use code generation or reflection whenever possible. For example, use Moshi or Kotlin serialization over JSON, which uses reflection. With code generation, the optimizer can more easily determine what code is actually used at runtime and what code can be removed. For more information about code gen versus reflection and how to choose libraries, check out Choose Libraries Wisely on the developer guidance. Now that we have seen how to debug R8 enabled builds, Ben is going to show you on how to measure the performance.
Thank you. This is going to be a very quick overview of measuring performance. So just a quick refresher. Users care for developers. User cares for the performance because they want a smooth and responsive app, and it leads to better user satisfaction. As a developer, you should care for technical performance and the metrics. That's also what we do is we help you with the developer experience here. And business owners usually care from performance perspective more on the performance indicators on the business side and things like rating and retention. And as you've seen, everything leads into the same thing with the technical performance. That is your key piece that you can play to satisfy the users here a bit more and also help your business owners. After you've done all the optimizations and improvements, you can use things like the Jetpack macro benchmark library to measure large-scale interactions. These interactions provide you more accurate and consistent results than saying, yeah, it works better than before. That's a very vague thing, but it works really, really very precise. So let me show you how it works in a moment. And it creates statistically significant data. By repeating the measurements over and over again, you will be able to see what is going on, not just in one run, where there might be a fluke in here, but you will have the possibilities to run this multiple times. The Jetpack macro benchmark library comes with a handful of important metrics straight out of the door. So for startup timing, you can use that to measure the time to first frame, also time to full display. Another one would be frame timing that you can measure with it right at the door as well. That gives you rendering information and the distribution of how your frames show up. So it gives you P50, 90, 95, and 99 as well to see how well your frames render, if the frames are over or under the vsync threshold. Can also give you information on CPU and memory consumption. Regression tracking is really good with that. And it also gives you the possibility to add entirely specific and detailed and custom queries for your use case. So you can measure anything that is happening on the device. Basically any trace, any data you can see here. So it gives you a lot of basic things as well, kind of to get started. But once you're out of the box and you want to play with it, use custom traces to get any information out of your trace that you want. Using it is pretty straightforward. You use the macro benchmark rule, you measure a couple of things repeatedly. In this case, we were using a startup and frame timing metric, and then say we want to have 10 iterations. And now it's just to write the user journey that you want to benchmark. And writing that is basically things like the user journey. We mean something like you start the app, you click a button, you scroll the content, you do a couple of other things, and then the test is finished. We have a new API for this. The UI automator has been massively changed for that. So let's take a look how that works. Starting the app, you just say start app, simple as that. Second one is when you want to click on something, you just select the element with this query, say on an element that has a string, for example, search. But I don't just want to find it, but I just straight away want to click on it. There we go, one line for this. Scrolling content, pretty much the same thing. We just say, is the content there that's scrollable? And then you fling down. It's very straightforward. It's very easy to follow as well. And you can do the same thing with more complex scenarios as well. So something that is editable, has a content description, which is called prompt. We want to enter some text. All in, well, 1.5 lines, but close enough. You can be more, you can even do other things. So if you know there's a view hierarchy or a composition hierarchy and you want to find what's going on in here without relying on IDs, you can just say, okay, what's going on here? I just want to navigate the entire hierarchy. So you can have nested calls here as well, and then click in there. You can do things like setting custom timeouts because, well, there's a default timeout built in, so you don't have to do any more waiting manually, but you can set your custom timeout if you know there's something that takes a long time where you have to wait a lot. You can do screenshot testing with it, so you can save directly to a file and read from that later on. You can also clear the app's data completely, so you can reset it to a state that you want it to be in the first place when you start the test. To use it, just use the dependency, currently 2.4 alpha 6, and let us know how it goes. If there's any questions, any problems with this API, we are very excited to hear what's going on so we can make changes before we stabilize it. With macro benchmark, you basically have the possibility to capture the performance data with all these built-in metrics, custom metrics. You use a new UI automator API, and then you run this on real devices. Real devices is important because, well, if you run it on an emulator, you basically test your computer, not your phone, or not the phone that you want to test on. You can also use things like Firebase Test Lab if you want to use remote device farms for that as well. You see, after that has happened, there's data here. What does this mean? Time to initial display on the median is like 2,800 something milliseconds. What does that mean? I don't really know. There's also a P90 here for frames that's over 6.2 milliseconds. Not really sure what that means. We provide you with a bit more information on that, and that is the app performance score that I mentioned earlier. That gives you the guidance you need. Basically, it tells you exactly, is this good or not? So you enter the animation issues that you have, how many frames are slow, what's going on here, and then you will get a evaluation. In this case, that basically tells you it's below average rendering performance, you should do something here, is the recommendation here, because that will help you to have a higher quality here. And you will also get an overall score. That overall score tells you how your app is scoring in the dynamic range as well as in an aesthetic range. But if you attract more information, it can be a lot more data that's in here. It will take a moment for you to understand where to look at. Usually you take the medians, because that takes out all the outliers, so the maximums and the minimums, and you can see what's going on in here in these repetitions, in these iterations. How does the initialization count look? Those are very custom metrics to some extent, and you can see exactly what's going on. And we have for rendering, we go usually for P95, P99, so that means that 5 or 1% are slower than, are worse, performing worse than this, and we want to improve those metrics. So let me give you a quick rundown again of the Androidify app to show you where we're going and where we can go. If the app is not optimized, we had a startup time of about 400 milliseconds. This is brilliant, but we're not going just for that. Just-in-time compilation is another key thing. When you want to talk about that, find me after the session. And this is about just-in-time compilation. It's baseline profile related and startup profile related. Can make your app initialization and runtime a lot worse if you have high just-in-time compilation counts. We've seen frame overruns like 7.4 seconds with 300 frames that were rendered. And the app size was about 18 megabytes. So looking at the data here, after we have optimized it, the data has gone down. So we have 21% startup time increased with this. Already very fast to begin with, not a lot to shave off, but it's already decreased a lot. Just-in-time compilation time went down, time went up here, but that doesn't really that much because I'll show you later on what that can do. This is not R8, but that's baseline profiles that come in here. And also, frame overrun has gone down dramatically for 95% of the frames, and we've also had rendered more frames in that time. And the app size has gone down by 73%. So that is just optimizing it with the R8 optimizer. Means installation time is faster, and also startup time can be faster with that. When we apply profile-guided optimization, we're basically pretty much eliminating, in that case, all the just-in-time compilation count, all the just-in-time compilation time. Class initialization drops dramatically. Startup time, again, dropped down a bit more. But basically, this is what a fully optimized app can look like with dramatic improvement with just a couple of tools. So using R8 to its full potential, using baseline profiles, startup profiles in the form of, that's both forms of profile-guided optimizations, and then measuring your performance gains. Those are three things we want you to do to keep your optimizations enabled. So right now you can enable optimizations, and well, we're going to do a challenge with the Spotlight Week that we're doing. If you use the hashtag optimizations enabled, we'll monitor what's going on there. If you have any questions during that time, pop them in there. You can get started right away, so get a bit of a head start here. And we'll take a look, and we'll see how we can help you out, whether that's with our new and updated guidance that we have, or directly any specific questions that you might have and that we can't solve with the guidance, because that helps you, and it helps us to help you a bit more with that. We talked about the guidance a couple of times. Take a look. It has seen significant updates. We have spent a lot of time making sure we have it as complete and as full for you so you can understand exactly how to configure those things. But this is where we are today, and thank you so much for your time. Do we have time for questions? No? Okay, if there's questions, just come here or find us during the conference. We're here. Thank you.